Alright, so we will be measuring our blood drops a little different when it comes to angles. You'll see that a blood at an angle is going to be elongated, and so you're going to have a width and a length, whereas we only had diameter for blood drops that were straight down. A couple things to note before we start measuring. You see this tail of the blood drop, or the little splatter pieces, that tells you where the blood hit, and then it went in the following direction. So this blood went in this direction when it hit the surface. When you're measuring, you do not include the tail. You are going to just do the main blood drop. The width is going to be the small side. The length is going to be the long side. So when we go to measure this, we are in millimeters. So to remind you, this is the centimeter side. So 1 equals 1 centimeter or 10 millimeters, because you would have to count all the little lines to get to 10. So when we look at the width of this blood drop, we find the fattest part. We are at 5 millimeters for width. And then for length, like I said, you do not include the tail, just the main blood drop. So we're going from the end of that main blood drop to the end of that main blood drop, and we are at 25, 6, 7, 8, 28 millimeters. And you are then going to find the ratio of the width to the length using just plain old division. So we are going to take and divide 5 by 28, which gives us this big long decimal. Give me like 4 of the decimal points. That'll be plenty. So the 7 rounds the 5 to 6. Now, if you are a math guru and have some fancy calculator and want to do the inverse sign, that way you do you, boo. But I am also giving you a sine chart. So if you look at the sine chart, you can see that it's the angle, the sine, the tangent. We do not need the tangent for right now. Do not cross it out. We will use it in another lab. Today we are using the sine and inverse sine column, so that's the middle column. And our decimal was 1.786. So we're going to look on here. So we're going to find 1.7, and then the next one is going to be 1.9. So your angle is going to be 10. Find the one that's closest. If it's like right in the middle, give me a 10.5. So this one is going to be a 10-degree blood drop, based on the inverse sine of the ratio of the width to the length. Refer back to this if you need any more help measuring, remembering direction, all of those things.